So a lot of people have been asking me the difference between enantiomers, diastereomers, epimers, anomers, and Miso compounds. So I thought I would kind of make this distinction for everybody so that they can kind of get it clear, because I notice it's pretty easy to get them confused with one another. Okay, so let's go start from the beginning. Enantiomers are non-superimposable mirror images. Okay, so if you remember before, this is just strictly every stereocenter is exactly opposite. Okay, so in this example we have R, and in this example we have S. You guys can figure it out from previous lectures how we did that. So this is R and this is S, and if we see here, they're mirror images of each other. Okay, we exactly mirror them, but they can't be superimposed. They can't put one on top of the other. Likewise, if we had RR, the enantiomer would be SS. Diastereomer, it differs by one stereocenter. Okay, it's at least one stereocenter different in regards to it's not exactly opposite from one another. Okay, and they're not mirror images, and that's what defines it from enantiomers. Okay, so in this example right here, we have something that's R and S, and here we have S versus S. Okay, so we'll figure it out on our own how we got R and how we got S, but you see it differs by at least one stereocenter. It's not exactly opposite. If this was an enantiomer, this one would be RS and this one would have to be SR. Okay, so it'd be exactly opposite. Now it's when it gets a little bit tricky. So epimers and anomers are actually a type of diastereomer. Okay, so diastereomer can be divided into an epimer, or it's just strictly a diastereomer on its own, not an epimer. Within the epimer, it can be divided into an anomer, or not an anomer, just a normal epimer. Okay, so that's the one thing that people kind of don't realize, is that epimers are still diastereomers and anomers are still epimers, and they're still diastereomers as well. So now that we kind of had that straight, we're going to be distinguishing between epimers and anomers. Okay, so what is an epimer? Okay, so an epimer differs in just one stereocenter. Okay, so generally when we talk about this, for the MCAT's purpose at least, we're talking about sugars. Okay, so differing by one stereocenter is going to be an epimer, and generally just sugars. Obviously you can have epimers that are not sugars, but for the MCAT's purpose, all that we're going to be dealing with is going to be the stereotypical sugar. Okay, so on the left I have drawn glucose, and on the right I have drawn galactose. And if you can notice that the only difference is in number 4. Carbon number 4 is different. Okay, it's different by one stereocenter, and that's exactly what an epimer is all about. Okay, it's just different by one, and that's all you need to know. It's just different by one stereocenter. We're going to contrast that with anomer. It's similar, but in the same time that it's a type of epimer, but it differs because of ring closure. And what do I mean by that? So if you remember from Ochem, you remember how glucose is actually made, how we get from the normal structure like this, like the Fischer projection, and the one that's in the ring structure. Okay? What happens is this O right here is going to bond with that carbon right there. And what's going to happen is this O is going to become the OH. So it's going to become this carbon number 1 OH. Okay? So because of that, this O is in no preference to go pointing up or pointing down. It can do either one. And so that's what the anomer is. The anomer is this carbon number 1. The anomer is different in stereochemistry by one carbon, but it's different because specifically of ring closure. So in this case, we're dealing specifically with sugar. You cannot have an anomer that's not a sugar. Okay? So anomers are alpha versus beta sugars. Okay? And how do we remember alpha versus beta? So this is what my teacher taught me. It's kind of funny, but it works. It'll help you remember it. So alpha looks like a fish. Beta, we'll worry about that later. But fishes in the sea and birds in the sky. Okay, so B is the birds. So B would be this one right here, and this one would be alpha. So fishes in the sea, that's why it's pointing down. Birds are in the sky, so that's why it's pointing up. So the last thing we're going to be looking at is Miso compounds. So Miso compounds, all it means is that it has stereochemistry within it. At least it has to have 2. But the difference is that we're not comparing one molecule to a whole nother molecule and saying, is it R versus S, is it enantiomer, diastereomers? All we're doing is we're saying that we're comparing it within itself, and it has an internal plane of symmetry. So for example, like this one, we see that if we fold them together, it'll be exactly the same. Alright, so it has an internal plane of symmetry, and that's all we need to know. In your chemistry classes or Ochem classes, you probably learned a couple rules to identify complicated Miso compounds, but for the MCAT's purpose, you just need to know simple ones. Simple Miso compounds is good enough.